You know what I love about science fiction? It shows us dreams. Beautiful, inspiring dreams about exploring the galaxy, meeting alien civilizations, traveling faster than light. And you know what I love even more? Physics. Real, honest, unforgiving physics that tells us what nature actually allows. And here's the thing that's going to disappoint some of you. Those warp drives you see in Star Trek, the ones that fold space and let you zip across the galaxy in time for dinner, they're not just difficult to build. They're not just beyond our current technology. They're physically impossible. And I don't mean impossible like we can't do it yet. I mean impossible like nature herself says no. Now that's a strong claim. So let me prove it to you. Let me show you exactly what physics has to say about warp drives and why the universe is constructed in such a way that you can't cheat the speed of light. Not now, not ever. Not with any technology, no matter how advanced. First, let's be clear about what we're talking about. A warp drive is a hypothetical propulsion system that would allow a spacecraft to travel faster than light by manipulating space-time itself. The idea is that instead of moving through space, you compress space in front of you and expand it behind you. You create a bubble, a warp bubble, and you ride this bubble across the galaxy while technically staying still inside it. It sounds clever, doesn't it? It sounds like a loophole. Einstein said nothing can move through space faster than light. But what if we move space itself? What if we surf on a wave of space-time? This idea was formalized in 1994 by a physicist named Miguel Alcubierre. He wrote down actual equations, real general relativity mathematics, that described such a thing. And the physics community got very excited because here was something that wasn't just science fiction hand-waving. Here were actual equations that seemed to allow faster-than-light travel without violating Einstein's relativity. But here's what people don't tell you. Here's what gets left out of the popular articles and the exciting YouTube videos. The Alcubierre drive and every other warp drive concept ever proposed requires things that don't exist, things that can't exist, things that violate the fundamental laws of physics so badly that nature herself stands up and says, absolutely not. Let me explain. The first problem with warp drives is energy. Not just a lot of energy, not just more energy than we can currently produce. I'm talking about energy that's negative. Exotic matter with negative mass and negative energy density. Now, what does that even mean? In our everyday experience, everything has positive mass and positive energy. A rock has mass. A photon has energy. These are positive quantities. They attract each other gravitationally. They curve space-time in a particular way. But the Alcubierre equations require something completely different. They require matter that has negative energy density. Matter that would push space-time the opposite way. Matter that would create a kind of anti-gravity effect. Does such matter exist? Well, there's something called the Casimir effect, which produces a tiny negative energy between two conducting plates in a vacuum. Quantum mechanics allows for little temporary violations of energy conservation on very small scales. But these effects are incredibly tiny, incredibly fleeting, and they don't add up to anything macroscopic. To create a warp bubble around even a small spacecraft, you would need negative energy equivalent to the mass energy of Jupiter, or the Sun, or, depending on whose calculations you trust, the entire visible universe. That's not negative energy that we could somehow collect or generate. That's negative energy that, as far as we know, simply doesn't exist in nature in those quantities. And it gets worse. Even if this exotic matter existed, even if we could somehow collect it, we'd have to arrange it in a very specific configuration around our spacecraft. We'd have to maintain this configuration perfectly while we're traveling. One small perturbation, one tiny instability, and the whole thing collapses, probably violently, probably destroying everything nearby. The energy requirements aren't just impractical. They're physically absurd. They require us to have access to types of matter and energy that all of our observations suggest don't exist and can't exist in the amounts needed. But let's say we somehow solve the energy problem. Let's say we found this exotic matter. We figured out how to arrange it. We built our warp drive. Now we have an even bigger problem. We have the causality problem. Causality is the principle that cause comes before effect. You flip a switch, then the light turns on. You throw a ball, then it flies through the air. Cause, then effect. This seems obvious, but it's actually one of the deepest principles in physics. It's what prevents paradoxes. It's what keeps the universe making sense. Now here's something Einstein figured out. If you can travel faster than light, you can violate causality. You can create situations where effects happen before their causes. You can create time travel paradoxes. Let me show you how this works. Imagine two people, Alice and Bob, traveling away from each other at very high speeds, close to the speed of light. Now, Alice uses a warp drive to send a message to Bob faster than light. From Alice's perspective, the message arrives at Bob after she sent it. Cause, then effect. Everything seems fine. But here's the weird part. From Bob's perspective, because he's moving relative to Alice, because of the way special relativity works, the message might arrive before Alice sent it. Effect, then cause. And if Bob immediately sends a message back to Alice using his own warp drive, Alice could receive Bob's reply before she sent her original message. Do you see what just happened? We created a time machine. We created a situation where information can travel backward in time. And once you can send information backward in time, you can create paradoxes. You can kill your own grandfather. You can prevent yourself from building the warp drive in the first place. Physics doesn't like paradoxes. The universe is consistent. It has rules, and those rules don't allow contradictions. So if warp drives lead to paradoxes, if they lead to causality violations, then nature must prevent them somehow. And nature does prevent them. The way nature prevents them is by making faster-than-light travel impossible. The speed of light isn't just a speed limit for things moving through space. It's a fundamental feature of causality itself. It's the speed at which cause and effect propagate through the universe. Here's another problem that people don't talk about enough. It's called the horizon problem, and it's absolutely killer for warp drives. Imagine you're sitting in your spaceship, and you want to create a warp bubble. You need to manipulate the space-time around your ship. You need to compress space in front of you and expand it behind you. How do you do that? Well, you need to send some kind of signal or field or force out from your ship to the region of space you want to manipulate. And here's the problem. That signal can't travel faster than light. Nothing can. So you can't affect the space-time in front of you faster than light can travel from your ship to that location. This creates a fundamental paradox. To create a warp bubble, you need to manipulate space-time faster than light. But to manipulate that space-time, you need to send signals that can only travel at the speed of light. You need faster-than-light capability to create the faster-than-light capability. It's like trying to lift yourself up by your own bootstraps. It doesn't work. You can't do it. Some people have proposed solutions to this. Maybe you prearrange the space-time somehow. Maybe you set up a network of devices that create the warp bubble from the outside. But all of these solutions involve either faster-than-light signaling, which we've already established is impossible, or they require you to already have the infrastructure in place at your destination, which defeats the whole purpose of exploring new places. The horizon problem is fundamental. It's built into the structure of space-time itself. You cannot affect regions of space-time that are space-like separated from you. You cannot reach outside your light cone. And without being able to do that, you cannot create a warp bubble. Now, all of the problems I've mentioned so far come from general relativity, from our understanding of gravity and space-time. But we have another theory that describes the universe, and it's just as important: quantum mechanics. And quantum mechanics has its own objections to warp drives. You see, when you create a warp bubble, when you dramatically curve space-time in the way the Alcubierre drive requires, you're not just affecting classical space-time, you're also affecting the quantum fields that permeate all of space: the electromagnetic field, the electron field, all the quantum fields that make up the standard model of particle physics. When you curve space-time severely, when you create the kind of exotic geometry a warp drive requires, you can create what's called Hawking radiation. This is the same kind of radiation that black holes emit. Space-time curvature causes the quantum vacuum to produce particles and energy. Now, for a black hole, Hawking radiation is very weak. It's negligible. But for a warp bubble, the calculation suggests that the Hawking radiation would be enormous, catastrophically enormous. The energy released would be enough to destroy the spacecraft, the warp bubble, and probably everything in the surrounding region. And there's another quantum problem. It's called the quantum inequalities. These are mathematical theorems that limit how much negative energy you can have in any given region of space for any given amount of time. They're derived from the fundamental principles of quantum field theory. And what these quantum inequalities tell us is that even if exotic matter with negative energy exists, you can't accumulate enough of it for long enough in a small enough region to create a warp bubble. The universe has built-in limits. Nature says you can have a little bit of negative energy, briefly, in a tiny region, but not enough to build a warp drive, not even close. These aren't engineering limitations. These are fundamental limits imposed by quantum mechanics itself. Let's imagine we solved all of these problems. We found exotic matter. We figured out how to avoid causality violations. We dealt with the horizon problem and the quantum problems. We're really stretching here, but let's imagine it. Now we have the stability problem. A warp bubble is not a stable configuration. It's like balancing a pencil on its point. Technically possible for an instant, but any tiny perturbation knocks it over. The mathematics of warp drives shows that they're riddled with instabilities. If the bubble encounters any matter, any energy, any irregularity in space-time, it could collapse. And when I say collapse, I don't mean gently dissolve. I mean catastrophically release all the energy involved in maintaining it. The energy equivalent of multiple stars released in an instant. And remember, you're traveling faster than light. You have no way to see what's ahead of you because light from obstacles ahead hasn't reached you yet. You're flying blind through the universe at superluminal speeds, and the slightest bump could destroy you and release enough energy to sterilize entire star systems. Even worse, some calculations suggest that particles and radiation would accumulate at the front edge of the warp bubble. By the time you arrive at your destination and drop out of warp, all that accumulated energy would be released forward like a cosmic death ray, incinerating everything in front of you. You wanted to explore strange new worlds? You'd destroy them before you even saw them. So why does nature make warp drives impossible? Why are there so many different barriers, so many different ways the universe says no? I think it's because the speed of light is not just a speed limit. It's a fundamental feature of how the universe is constructed. Space-time, causality, quantum mechanics, they're all woven together in a consistent way. And that consistency requires that information, that cause and effect, cannot propagate faster than light. If you could build a warp drive, you'd break that consistency. You'd create paradoxes. You'd violate the fundamental principles that make the universe comprehensible and lawful. And nature doesn't allow that. Nature is consistent. The laws of physics work everywhere, at all times, in all situations. They don't have loopholes. They don't have cheat codes. When Einstein wrote down his equations, when he discovered that nothing can travel faster than light through spacetime, he wasn't just describing a technological limitation. He was describing something fundamental about the structure of reality itself. The speed of light is woven into the fabric of causality. It's built into the relationship between space and time. It's connected to how particles and fields behave at the quantum level. It all fits together in one beautiful, consistent, unbreakable whole. And warp drives? They try to break that whole. They try to tear apart the consistency of physics. And nature, in her infinite wisdom, has put up barrier after barrier to prevent it. Now, does this mean we'll never travel to the stars? No. It just means we won't do it with warp drives. We'll have to do it the hard way, the slow way, the way that respects the laws of physics instead of trying to circumvent them. Maybe we'll build generation ships that take centuries to reach nearby stars. Maybe we'll develop suspended animation and freeze people for the journey. Maybe we'll send robots and artificial intelligence instead of biological humans. Maybe we'll find ways to go faster using fusion drives or antimatter rockets or light sails, getting up to significant fractions of the speed of light but never exceeding it. These approaches are hard. They're not as exciting as Star Trek, but they're honest. They work within the rules nature has given us instead of fantasizing about breaking those rules. And you know what? I think that's more impressive. I think building a civilization that can cross interstellar space over centuries, that can maintain purpose and knowledge and culture across generations. That's more impressive than pushing a button and magically appearing somewhere else. The universe is big, unimaginably big, and the speed of light is slow compared to those distances. That's just reality. That's what nature has given us to work with. But reality is wonderful. Reality has structure and rules and consistency. And by understanding those rules, by working with them instead of against them, we can still do amazing things. Just not warp drives. Nature says no to warp drives. And when nature says no, she means it. Thank you.